they give me the PID also. So now, if I'm looking at Java, and most machines have more than one JVM running, or more than one process named Oracle running, for example, you're going to need to hone it down a little bit further. Now I'm looking at the PID also. So now I actually have 4 columns of output. I have the, let's see. So I have the probe function, which is IOCTL. I have the exec name, which is Java. I have the PID. So all these JVMs are the same PID, and then the count, which is the number of times that instance occurred when the probe fired. Okay. So let me go back to this. All right. So that's a D program. So there's your probe, there's your optional predicate, and then the action to take when the probe fires. And here's an example of this program being executed on the command line. So when you're using dtrace, you could do things in one of 2 ways. Typically you're going to start with the command line, but then as you get more sophisticated and you begin instrumenting more probes and taking more actions, the command line gets a little cumbersome. Now you want to write a D script. So you just put it all in a D script and you script it, and this has 2 advantages. It makes it easier for you to manage your D, number 2, and then just like any other scripting language, as you begin writing and developing your D scripts, you begin building a toolbox. You have your D scripts that you're going to carry around with you, and you're going to use them over and over and over again, and make minor modifications to them as you go from problem to problem to problem. All right. So now that you're completely confused, let me see what I want to do here. There's one or 2 more things I want to do from a groundwork point of view. Because I need to tell you a little bit more about this, because you've seen me use it a couple times. And again, we can't teach you all of dtrace. So one of the features of dtrace is, in addition to supporting a great many variable types, internal variables as well as user-defined variables, dtrace has a special set of variables called aggregations. And aggregation variables are variables that store the result of an aggregating function. Count is an example of an aggregating function. There's about a half a dozen aggregating functions in dtrace that aggregate data for you and make it easy for you to have pruned down meaningful data that you can analyze. The count aggregating function is a simple count. Every time this probe fires, count increments. That's all it does. It counts. Now, an aggregation variable stores the result of an aggregating function and is identified by this @ sign. So this @ sign is a special symbol to dtrace. It means this is the name of an aggregation variable. And in this case, the variable name is reads. Like any user-defined variable, you can call it whatever you want, as long as it doesn't conflict with an existing dtrace name. You can call it, you can name it after your pet macaw parrot if you want to. It just has to be a unique string. Aggregation variables look like associative arrays. For those of you that have been doing some programming, Perl, Awk, any number of languages today, they all pretty much support associative arrays. An associative array is an array that allows you to index the array with 1 or more keys. And that's what's inside the square bracket. These are the keys that I'm using to index the array. Typically, they're the names of dtrace variables that allow me to provide meaningful information to the data that I'm aggregating. So in this case, what I'm doing is I'm saying, every time I execute the read system call, if the process name is Java, I want to count it, and I want to index it by the PID and the path name of the file. So I'm basically using dtrace to say, every time a Java process reads a file with the read system call, I want to know the PID and I want to know the path name. So I can actually track what files are being read by the Java processes running on machine. That's an extremely powerful bit of information that you're getting with a relatively simple dtrace script. Okay. So, all right. So that was kind of a trial by fire on the components of dtrace. So let's talk about some use cases and stuff, and show you a little bit more about what you can do with dtrace. But before I do that, does anybody have a question about anything that I've talked about up to this point? I realize that I went over a lot of information in just a couple slides. But unfortunately, as I said, it's a complex topic, and there's just no easy way to do a 90-minute dtrace talk easily. Okay. So when you're getting started, when are you going to use dtrace? Well, you're going to use it. I mean, dtrace was created to give us the ability to troubleshoot production systems. That's why we created dtrace. The inventor of dtrace, Brian Cantrell, and his co-workers determined, going back probably about 10 years now, that when it came to being able to effectively troubleshoot and root cause problems in a customer's production environment, we really just didn't have the right tools to do it. And for those of you that have been Sun customers for many, many years, I hope you never lived this, but there have been situations where we had problems on machines in production, and the only way we ultimately were able to solve it was to ask the customer, okay, when it does that, I want you to hit these keystrokes and get a core done. Oh, great. So now I'm down for an hour and a half, right? Because I literally have to pull off the machine, I have to wait till it writes its core file, then I have to reboot it and bring it back into production. Not a good way to troubleshoot a problem. And Brian has a myriad of stories, as do I, about horror cases where we just came away realizing we didn't have tools sufficient to do the job, to troubleshoot performance problems and pathological behavioral problems with our systems without being overly intrusive in our customers' production environments. That's why we invented dtrace. So it was designed to be used in a production environment. Dtrace is safe to use. One of the primary design tenets of dtrace was that it was safety. It will not harm your machine or corrupt your data. Will it have a probe effect? Will it slow your machine down? Yeah. Potentially, yeah. The probe effect of an individual dtrace probe is minimal. It's on the order of under a millisecond. So the probe effect of dtrace is going to be pretty much commensurate with the number of probes you enable. So for example, if I look on my Solaris instance here, and I said dtrace-l, list all the probes, and tell me how many, I've got 75,000 probes on my little Solaris instance here. If I enable all 75,000 probes, we can all go to the pub, because it's going to take about 20 minutes for dtrace to turn them all on, recognize my Control-C, and turn them all off again. So you do need to use care when you're using dtrace in a production environment, especially on a large, busy machine. It can have a probe effect. Having said that, I've been using it in production environments for over 5 years, and I've never done any damage. That's not completely true. There was this one time. I did take a production system offline. I didn't damage it, but it was in a financial space. It had watchdog timers that said, hey, if I don't get a response in 300 milliseconds, drop offline. And so it was just one of those real-time things. But anyway, okay. But dtrace is very safe to use. And there's a whole bunch of other safety mechanisms built into dtrace. In the interest of time, I can't get into all of it now. For example, dtrace has a built-in watchdog timer. When you use dtrace, it actually monitors itself. What it does is it sets an internal watchdog timer using an interrupt mechanism. And it says, I have to get this internal interrupt every 10 seconds. And if 10 seconds go by and I didn't get this internal interrupt, I'm going to assume the machine is just really, really busy as heck, or it's wedged, and I'm going to exit. And dtrace will just clean itself up and take itself out of the equation. So dtrace does police itself using a watchdog mechanism. And there's other safety features built into it as well. I didn't want to forget to mention that because that's really, really important. All right. So when you're going to use D-Trace, you're looking at a problem. Maybe you're not looking at a problem. Maybe your machine is